Okay, welcome back to class. Do I have everyone in class now? Do I have everyone in class? Okay, I start again with the solution to this question. So, let's take the solution again. Now, I said how many ways? In how many ways can 3 men and 2 women be chosen from a group of 5 men and 6 women? Now, we are dealing with men and women. Now, how many ways can I select how many men out of 5 men? I want to select just 3 men. And the word "and" now is multiplication. Out of 6 women, I want to select just 2 out of them. This is the translation. Now, we can now introduce our formula that says n combination r equals n factorial, n minus r factorial, r factorial. So here comes, this implies that here becomes 5 factorial over 5 minus 3 factorial, then 3 factorial, and 6 factorial over 6 minus 2 factorial, 2 factorial. So that is just the translation of what we have on the board there. Now, since we have that on the board, what do we do next? What we do next is to break down these 2 scenarios in a better translation. So let's break it down this way. So here I say that here 5 factorial divided by 5 minus 3 is 2 factorial, 3 factorial, and 6 factorial, 4 factorial, 2 factorial. That is all we have there now. So I can clean this part, then continue with my solution. Now, the shortcut method we use in permutation. Let's try that here also by saying 5 times 4 times 3 factorial is the biggest denominator here. So you end it there. 2 factorial, 3 factorial, and 6 times 5 times 4 factorial is the biggest denominator here. So you end it there. 4 factorial, 2 factorial. So here, 3 here cancel this 3. 4 here cancel this 4. So we are left with 2 here 1, 2 here 2. 2 here 1, 2 here 3. Finally, we have 5 times 2 here. And 3 times 5 here. Here becomes 10 and 15. And when you multiply these 2 together, final answer becomes 150 ways. This is the number of ways you can select or choose 3 men and 2 women from a group of 5 men and 6 women. Now, is this solution well clear to you, everyone? Is this solution well clear to you?
Yes, sir.
Thank you very much. Now, I will be going inside your past question to pick out 1 or 2 questions that you might be coming across on your post-UTME day. So, let's dive into our past question. From my past question here, please, in the last session, I said you guys to make sure you have this past question at hand. It is what we are using in our class here. And also, I'm not supposed to do this, but due to the fact that I have, not everyone is an island of knowledge, I will always advise students who are having difficulty in mathematics to enroll in a private tutoring section with me. I can guide you through with every of your needs in mathematics. You need me? reach out to your coordinator. They will give you my contact. I don't share my contact online. Reach out to your coordinator. They will give you the right contact to reach out to me. Please get this past question at hand. Practice more and practice better before your exam. And see you on the day of your exam with flying colors. Here I have to my past question, page 2. Page 2 and question 10. Page 2, question 10. Page 2, question 10. Page 2, question 10. Here comes the question on the board. I'm only writing this on because the question is not that very much. Now, the question here says that in how many different ways? Okay, it says there are 8. There are 8. There are 8 men and 9 women. Women on a committee. On a committee. Full stop. In how many ways? In how many ways? In how many ways can a committee, okay, a subcommittee of 2 men and 3 women be chosen? Now, we have a question on the board. We have a question on the board that we want to address. Class, listen up and listen very good. There are 8 men and 9 women on a committee. That's the question. In how many ways can a subcommittee of 2 men and 3 women be chosen? The word chosen requires combination. Arrange requires permutation. I repeat, the word chosen, selected, requires combination. The word arrange, form, requires permutation. Take note of those words. Now, this is the translation of what we have on the board. There are 8 men and 9 women. So we have men and women. How many men? 8 men. Out of 8 men, we want to select how many? 2. And out of 9 women, we want to select how many? 3. That is what the question asks us to do. There are 8 men and 9 women on a committee. In how many ways can a subcommittee of 2 men, yes, 2 out of 8, and 3 women, 3 out of 9, be chosen? That is the question. Here comes the solution. So we use the same logic. The word and means multiplication. The word or means addition. Here we have 8 factorial over 8 minus 2 factorial, 2 factorial, and 9 factorial, 9 minus 3 factorial, 3 factorial. Now, the next thing we do is what? Simplify further. 8 factorial over 6 factorial, 2 factorial, and 9 factorial over 6 factorial, 3 factorial. Now, since we have all these 3 points, then we can now start by summing further. So here becomes 8 times 7 times 6 factorial is the biggest denominator here, divided by 6 factorial, 2 factorial. And here we have 9 times 8 times 7 times 6 factorial is the biggest denominator here. So we end it here, 6 factorial Then 3 factorial is now 3 times 2 factorial. Because 3 factorial is not 3. 3 factorial is not 3. Take note. So here we can now simplify. 6 here cancel the 6 here. 6 here cancel the 6 here. 2 here 1, 2 here 4. 2 here 1, 2 here 4. 3 here 1, 3 here 3. Are we good to go? Then here we are left with 4 times 7. And here we are left with 3 times 4 times 7. So final answer here is 28 times 3 times 4 is 12. 12 times 7 is 90. 12 times 7 is 84. 84. So when you multiply these two together, then you have the final answer, the number of ways in which you can arrange or choose 2 men from 8 men and 3 women from 9 women. So let's multiply 84 by 24. Sorry, 28. 8 times 4 is 32. 8 times 8 is 64. Plus 3, 67. 2 times 4, 8. 2 times 8, 16. Then when you add them together, 15. I have 3, then 1. So 1, 3, 5, 2 ways. Class, is this solution well clear to you? Is this solution well clear to you? Any question? Any question? Any question so far? Okay. In the absence of no question, I can proceed to another question from my past question here. Okay. All right. I have one more question here. Open to page 56. 56. Question 15. Page 56. Question 15. Page 56. Question 15. I can write the question also. So here comes the question that says, in how many ways? In how many ways can two students be selected from a group of 5 students? So I have 5 students in a debating competition. Okay, for the sake of correction, yeah, the original calculation is 2352. Please, 2352. Please correct that before you write out this next question. 2352. The answer to the previous question is 2352 ways. That's the number of ways you can select those men and women. Okay, I have one question on the board. In how many ways can 2 students be selected from a group of 5 students in a debating competition? This question is very, very straight, simple, and direct. Are we there? We are selecting number of students. Out of 5 students, we want to select just 2. So how do we go about it? 5 factorial over 5 minus 2 factorial, 2 factorial. So this becomes 5 factorial over 3 factorial, 2 factorial. This then becomes 5 times 4 times 3 factorial. 3 factorial, 2 factorial. Then this one can take away this one here. 2 here 1, 2 here 2. So we are left with 5 times 2. And that is 10 ways. 10 ways. 10 ways. It is simple and direct. Any question relating to all I've been solving in class? Post-CTME questions are very, very simple questions, but they expect you to fail them. That is the logic behind them. They are simple questions, but they expect you to fail them. The logic behind them. That is it. Any question from you? Can I get one question from any of the students there? One question. Just one question. One question, please.
Excuse me, sir.
Okay, I'm with you.
Sir, I'm not really sure if this is permutation or combination, but it's one of the two, sure. Are you there, sir?
Okay.
So it says, in how many ways can a group of 5 men and 2 women be made out of a total of 7 men and 3 women?
That is combination. Okay. Is
Oh.
the question in your past question there?
Yes, sir. Page 3,
Okay.
number 30.
Tell me where it is in your past question. It is combination.
Page 3, number 30.
Page 3, number 30. Okay. Thank
Yes,
you
sir.
very much. So I can write it out on the board. All right. Page 3, number 30. It is combination. Okay. So we'll see why it is combination. Why solving our solution. So we have in how many ways? In how many ways can a group of 5 men and 2 women be made out of a total of 7 men? 7 men and 3 women. Now, here comes the solution. Follow me up, class. In how many ways can a group of 5 men, 2 women be made out? Be made out. You can see that encircle line. Be made out is just a translation. You see, there is something I do in my private section when I have a one-on-one class with students. I will tell you, you are not just coming to learn mathematics alone. You are coming to learn both math and English language. Because if you can't explain your English, then there is no way you can tackle any calculation. The word says be made out. And remember, I said permutation deals with arrangement, forming. Combination deals with selection, choosing. When something is made out, that means you are choosing something out or you are selecting them out of it. That is why I circle that word, be made out. So in how many ways can a group of 5 men and 2 women be selected, be made out, be what? Chosen out of a total of 7 men and 3 women. So you start by saying men and women. How many men out of 7 men? We want to choose those 5. And out of 3 women, we want to choose those 2. So here comes solution. 7 factorial, 7 minus 5 factorial, then 5 factorial, and 3 factorial, 3 minus 2 factorial, then 2 factorial. So here comes 7 factorial, 2 factorial, 5 factorial, and 3 factorial, 1 factorial, 2 factorial. So I am bringing it up yet again. Men and women. Men and women. Men and women. So the men and women here says that 7 times 6 times 5 factorial is the biggest denominator I have here. So I end it there. 2 factorial, 5 factorial. And the next one says 3 times 2 factorial. That's the biggest denominator there. 1 factorial, 2 factorial. So 5 here cancel this 5 here. 2 here cancel the 2 here. So 2 here 1, 2 here 3. 1 cannot cancel anything here. So we are left with 7 times 3 and 3 times 1. So finally I have 21 times 3. And our final answer is ending to give us 63 ways. So 63 ways is the number of ways you can what? Make out 5 men out of 7 and 2 women out of 3 women. I hope I've made myself clear with your question. Any other question? Any other question? Any other question?
Yes, sir.
Okay.
Page 2, question 8.
Page 2, question 8.
Yes, sir.
Okay. Page 2, question 8. Page 2, question 8 is permutation. We did that in the last class. Do you want us to show the solution?
Yes, sir.
Okay. Permutation. In how many ways? In how many different ways can the letters of the word George be arranged? All right. I love this question because it comes with condition. It comes with condition. Now, you all have your past question there. So, I am only showing the solution. J-U-D-G-E. Now, look at this word. They said that in how many ways can the letters of the word George be arranged such that vowels always come together? Now, the condition in the question says what? Vowels always comes together. If I were you, I will open my eyes, I will open my ear, I will open my nose. Everything that the Lord has given me, I will open it to learn this question. Now, how many vowels do we have in the question? I want your response.
2.
How many vowels? 2 vowels, right? Now,
Yes, sir.
before you guys identify your vowels, how many alphabets do we have all together here?
3.
5.
Five. So we have number of letters there is 5. The number of ways we can arrange the word dot is 5. Are we there?
Yes.
Now, I asked, how many vowels do we have? You said 2, Abina. Now, the condition in the question says that what? The vowels must come together.
Together.
Now, if the vowels are coming together, that means you regard every vowel there as one alphabet. Yeah.
Yes, sir.
Yes.
Now, we have grouped the vowels together as one alphabet. Now, how many alphabets do we have all together now? Yeah.
5. 4.
4, because UE is now as one alphabet. So we have the new N as what? 4. Now, here comes how you can solve your solution. Okay, from here, number of ways you can arrange the letters of the word dot says it is 5 factorial over it is 5 permutation 5 because we have no repetition of letters. And this one end up giving us 5 factorial already. Divided by 5 minus 5 factorial. That is 5 factorial over 0 factorial. So you end up having 5 factorial, which is 120 ways. Are we there already? That is for
Sir,
this
excuse me, sir.
man. Yes.
Sir, this
Yes.
permutation 5, this 5P5.
Yes.
I thought that
Okay.
the 5 that is supposed to be R. Since there
Yes.
is no
Yes. Yes. Let me
there's no
bring it
repetition.
outside here for you to see.
Oh
It
yeah.
is 5. The first 5 is for the whole alphabet. Are we there?
Yes, sir. Yes, sir.
Permutation, the next 5 is because each and every alphabet are not repeated.
Yes, sir.
So we have non-repeating alphabet. This one is standing on its own 1, standing on its own 2, standing on its own 3, standing on its own 4, standing on its own 5. That is why I have
Yes,
this
sir.
5 here. So here
Okay, sir.
becomes 5 factorial, 5 minus 5 factorial. Then here becomes 5 factorial over 0 factorial. 0 factorial is 1 already. So 5 factorial is 120 ways. That is just the solution without the condition. Are we there?
Yes, sir. Yes, sir.
Now, because the question gave us a condition, this is not the right solution. Is that clear?
Okay. Yes, sir.
The right solution with the condition is not coming with this man here.
All right.
So how many alphabets do we have all together when we join the vowels together?
4.
4.
4. So we have 4 here. Permutation. Do we have repetition of letters?
No.
No. Since there is no repetition of letter, it is 4 permutation 4. So we have 4 factorial, 4 minus 4 factorial. That is 4 factorial over 0 factorial. And 0 factorial is always 1. So 4 factorial equals to, that's 24 ways. 24 ways. Is it work clear to you guys? Is it work clear to you guys?
Yes, sir. Yes, sir.
Your answer is option P. Okay? Now, if you check the solution, if you check the option given to you, you can't find the first answer there, 120 ways, isn't it? That tells you that what? The first answer here does not ask condition. But you find the second answer there in your option. That tells you this is the right solution because of the condition. Is that clear, class?
Yes, sir.
Yes, sir.
Now, I will bring this class to an end now because we are time factors and we have just limited time for the class. Okay, if you have questions relating to permutation and combination, please prepare your question against the next class. I repeat, against the next class. Now, I was trying to patronize you guys with a section with me, because if you need me to enroll a private tutoring section with you, just reach out to your coordinator. They'll give you my contact. And mind you, the past question is still very much available here at the center here. Please make sure you purchase a copy of this past question. It is very well okay. Expert has verified it. That what questions there are questions that are set in your post-UTME back to back. Please get familiarized with the past question. We have it very much available at our center here. And for those who want to enroll in a private session with me, reach out to your coordinator. Then they will give you the direct contact to reach out to me. So I'll leave you guys to enjoy the rest of the day. Please don't end the class here. Practice make perfection. Practice on your own at home. So enjoy.